Hello, this is Nick of Time. Welcome to this, our 23rd talk in our series on the physics of time. This is our third short argument about why we need a description of the physical world. We're going to show that special relativity's symmetric equations do not describe the physical world. A relativist may say, well, gee, I never claimed that special relativity described the physical world. Good, we're in agreement. But, as we've shown earlier from, for example, GPS data, that shows that we have physical clock slowing as a function of absolute velocity. Hence, the facade of the special relativity view is not totally adequate, because underneath that, we can see what's really happening physically. And the special relativity view does not describe the physics of what's happening physically. That's the point we're making. Okay, again, as we've done before, we'll start off the discussion by assuming that special relativity does describe the physical world, and we will reach a contradiction, and in that way prove our point that special relativity does not describe the physical world directly or describe what's happening physically. First point, special relativity claims that all inertial observers' views are equally valid. Second point, let's take a frame that is moving at a velocity relative to our sun that's arbitrarily close to the speed of light. Let's say it's within 1 part in 100 million of the speed of light. In the context of special relativity's length contraction and mass increase as a function of velocity, the frame's velocity, the observer's frame velocity, the depth of our sun, and hence its volume, would contract to be arbitrarily small, and its mass would increase to be arbitrarily large, and hence our sun's density would become arbitrarily great. Okay, we have to go to the next slide to continue the argument. That arbitrarily great density implies that the sun would become a neutron star or a black hole, but it isn't. That frame has a view that's inconsistent with physical reality. So in the context of special relativity and the context of all frames have equally valid views, we come to an inconsistency if we're assuming that the frame's view describe physical reality. Okay, let's do a little critical thinking here. Let's say a relativist immediately replies, because he wants to defend his strongly held belief system. Let's say he says gravity and neutron stars and black holes are outside the domain of special relativity. Well, that's not a relevant counter-argument, because we're showing that the view of this hypothetical frame is inconsistent with physical reality. So it doesn't matter whether that aspect of physical reality is within the domain of special relativity. The view is inconsistent with the physical reality. Last point. Or the relativist might say, but I interpret special relativity as describing the just observed and not physical effects. Again, that's not a counter-argument. That's an agreement with what we've been proving. The point is that if special relativity is confined to the just observed and not physical effects, we now see from the data that that's a limitation on special relativity, because the empirical data is saying that beneath the special relativity view that's presented is a deeper view, a view that describes the physics of the physical world and a view of what's actually happening physically. So again, in conclusion, we've shown that special relativity is not describing the physical world directly, and that's an important point. For those of you who have been following my talks in real time, I will just mention that I'm going on to a couple of other big projects, so I will not be putting up presentations as rapidly as I have been doing. The next couple of talks should be very interesting. They'll talk about what relativists say to counteract these descriptions based on the GPS data. And related to that, we'll be talking about the treatment of the set of inertial frames in special relativity as if those frames were special in the terms of physics. And a misunderstanding, I contend, occurs in that view of the relativists. They may be unique in one sense, but not in the sense that's implied by the relativists' counter-arguments. So those should be interesting, but I haven't even developed them yet, so it will take a little while to get those done. Thanks very much for joining me today, and hope you'll join me again when we talk about those two important topics and other topics to come.